What I have on my right is our traditional tank design and the industry's traditional tank design. As you can see, it's got nipples and elbows and bushings and many leak points. That has been with us with the industry since the beginning, 1972. And we decided that in lieu of the complexities associated with this design, we've developed our new design, which is using manifold technologies, using thermistors, transducers, redundancies, some of the things that we're discussing here today. If you have a truck that goes down, what will happen is it could cost thousands of dollars an hour. So we designed some redundancies built into the system to prevent that. So if there is a fault with the system, that the truck will continue to run, the systems will continue to operate, the users will continue to be able to fulfill their job and the requirements that they're doing during the course of their days. The components that you see kind of scattered in this area are built into just this simple device. And it's all JIC fittings, it's O-ring fittings, so it reduces leak points by about 60 to 65% from traditional methodologies. The other side of that is this manifold assembly, and that replaces a number of these components as well, including the thermo-valve, the thermistor for gathering temperatures.
Another feature on the new tank design is inside the tank there's a coalescing element, and that element is what we call secondary separation, separates the air from the oil. Our new element has 50% more capacity to it, so with that, from our customer standpoint, typically that's a serviceable item. You have to change it out every so often. When we increase the capacity of that through the tank design, we're able to go a lot longer between maintenance intervals where that has to be changed. I know on a spin-on type, we looked at that tank out there with the spin-on coalescing filter on the outside the tank. That has to be changed annually. That's once a year, and that's an expense to the customer. With this type of system, and that's like maybe 1 year or 500 hours. This particular element inside of here is probably going to be a 6,000 hour element. So probably it's a good chance for the life of that truck you're never going to have to change that element, and that's a tremendous savings. We talk about fleets that have a number of vehicles in their fleet. As a truck goes to a job site in our northern climates, you can have condensation and water inside the compressor, or the oil can get, when it's super cold outside, minus 30, minus 20, whatever, the oil can get very sludgy and heavy and stuff like that. So we patented the design where inside the tank, coming off the engine coolant, there's a copper tube that comes into the oil bath and off the engine coolant. So as you drive to the job site, the engine coolant basically preheats the oil as it gets to the job site. So therefore, when you get to the job site, you already have warm oil, and that's better starts. It takes moisture out of the oil. People in northern climates would buy cold weather kits to put on their tank and stuff like that, so it doesn't freeze and stuff like that. With this thing, they don't have to buy that cold weather kit. It's kind of automatic, and it just preheats oil as you drive to the job site. So that works in all these redundancies and I'll show you some of the redundancies on the VTEC. That works in conjunction with our brand new VTEC design. One of the critical things is that previous speed controls basically had a high and a low. So anytime you start your compressor, you start to use air, the engine would elevate to a high speed, and it could be at 1,700 RPMs or 1,600 RPMs, thereby consuming fuel, making noise, more wear and tear on the engine. With the new control system, it's infinitely variable. So when you start your compressor, it goes to compressor idle, and it'll just stay at compressor idle. If you use this, maybe only 30 or 40 CFM of the partial capacity of the compressor, that engine will just maybe not even ramp up at all. But it's variable, so it's based upon air demand. So the engine speed is relative to air demand. So if you use a little bit of air, the engine will just go up a little bit. If you use more air, it'll go up a little bit. So it saves fuel, wear and tear on the engine. That's a key benefit of the controller.
We designed a new advanced control system with the new generation VTEC. It has a lot of features that we haven't had in the past. One of the biggest ones is if a customer used to have to take a truck out and have a program, spend money on it. Now we program everything right in the controls, go through the J1939 codes and the CAN bus. So basically a customer gets this out of a box, installs it, the truck ramps up to the correct RPMs all on its own, so they don't have to spend the time and the trouble of taking to a dealership program. So that's one of the big things for us there. really solved a lot of issues for us. The controls are really advanced. It supports all the redundancy Greg was just telling us about, double thermistor, double transducer. Any problems, it indicates a fault on the screen. It clearly tells the mechanics or the people operating what is wrong with the system. We have different counters in the controller where we count down on the maintenance. When you need to do it, we'll flash up on the screen, tell you, hey, in 100 hours, 50 hours, you're going to need to do maintenance. It'll tell you what part numbers to order for the maintenance kits. On the redundancy system, we've put 2 transducers, 2 thermistors for protection. We have advances in our sensors. We're not looking that there's going to be failure, but the importance is when a customer is out assigned to a job site and they have to get their job done. If the truck broke down on something like that, going back in, had to reschedule people come up, it could be a couple $1,000s, and then you need to get the work started again. So the benefits of the redundancy, basically you're preventing that from happening. So if you have a fault on one sensor, it's going to tell you when it goes back to the garage, they can fix it at night and keep doing their job.
I guess, as Ralph said, the secret sauce is in the logic built into the VTEC controller. So it automatically knows. When one fails, it automatically knows to go to the other system.
Seamlessly.
Yeah. So there's no interruption
There's no
operation.
switching.
So it's all built into the logic. And that was a lot of logic. Ralph said there's a lot of code to make that happen. So that's kind of where the VTEC controller works hand in hand with the stuff on the tank. They kind of work together.